गुड मॉर्निंग फ्रेंड्स। आज हम MSc फिजिक्स सेमेस्टर फर्स्ट में बाउंड्री वैल्यू कंडीशंस डिस्कस कर रहे हैं। कल भी हमने किया था, आज उसी कंटिन्यू करते हुए आगे बढ़ते हैं। कल हमने कैलकुलेट किया था कि एक डाइलेक्ट्रिक मीडियम है, दूसरा उसके सामने दूसरा डाइलेक्ट्रिक मीडियम है। यदि एक डाइलेक्ट्रिक मीडियम में चार्ज जिसका ε1 डाइलेक्ट्रिक कांस्टेंट है उसमें रख दें तो जो इसकी इमेज बनती है वो क्यू डैश वो सेकंड उसमें बन जाती है जिसका डाइलेक्ट्रिक कांस्टेंट ε2 है। तो उसको हमने रिप्लेस कर लिया था कि जो ε1 में क्यू डबल डैश चार्ज था उससे हम रिप्लेस कर सकते हैं। जो कल हमने कैलकुलेट किया था उसका जो रिजल्ट आया था वो था क्यू डबल डैश इक्वल टू ट्वाइस ε2 डिवाइडेड बाई ε1 प्लस ε2 डिवाइडेड बाई द क्यू। इससे क्या निष्कर्ष निकलता है? कुछ इंपॉर्टेंट रिजल्ट्स। फर्स्ट, from the equation 13 we can conclude that q double dash is always positive whatever the value of the ε1 and ε2 because there is the no negative concept here. But the charge q dash depends on the ε1 and ε2 is given in the equation 12. We have right that is the minus of the q dash equal to minus of the ε1 minus ε2 divided by ε1 plus ε2 multiplied by the q. So if the charge q dash is depends on the ε1 ε2, if the ε1 is greater than ε2 then q dash is positive, then there will be the repulsive force between the q dash and q because both have the same positive signs. On the other hand, if the ε1 is less than the ε2 then the q dash is the negative, then there will be the attractive force between the q dash and the q. That is we have displaced by the figures. See the first case. If the ε1 is greater than ε2 then there will be the repulsive force because the image charge in the second medium is also the positive, q dash is positive, so there is just like the repulsion between these two. जो इलेक्ट्रिक फील्ड लाइन्स होती है वो भी एक रिपल्सन की तरह रिप्रेजेंट करती है. Second case, when the ε1 is less than the ε2, in that case there will be q dash is the negative, so there is the attractive force. The field lines so will be just like the converging, so that will be the nature of this one. We can decide the nature of the force. Now the third boundary conditions, that is polarization charge density or the bound charge density. As earlier discussed, the surface charge density in the form of the polarization vector we have write sigma b is for bound, that is equal to the p vector dot nk. P is the polarization vector and that is the dipole moment per unit volume, because we know very well the dipole moment per unit volume q into d by the volume qd, that is so d by the volume, so it will be the q by area, so this is equal to the surface charge density. But for the dielectric medium, the relation between among polarization vector and the electric is given this one. Capital P equal to the epsilon naught chi e and the epsilon r equal to 1 plus chi, so chi equal to epsilon r minus 1 as yesterday we have calculated. So the polarization vector P equal to epsilon naught multiplied by the epsilon r minus 1 into the epsilon, so this gives epsilon 0 epsilon r minus epsilon or epsilon minus epsilon 0 e. So this is the relation between the polarization vector and the electric field applied. So for the two mediums interface, the total surface bound charge density between the two mediums is given the sigma p for polarization, sigma b1 plus sigma b2, that is correlated with the first and second medium. So for the first we can write ε1 minus ε2 ε0 multiplied by the e1 vector dot nk, and the second के लिए ε2 minus ε0 e2 dot nk. But we know the electric field is equal to the minus of the del phi 1, so we can write like this one. Here you have to write minus del phi 1 and the second is also same conditions, so we can write that is minus of the ε1 minus ε0 del phi 1 by del z, and the second case is the same conditions, the ε2 minus ε0 del phi 2 by del z. It will also the minus sign in the equation for also, please change it. But we know that the phi 1 equal to 1 by 4 pi epsilon q by the x square plus y square plus z minus d square power half, and so इसका डिफ्रेंशिएट करें del phi 1 by del z, can obtain the 1 by 4 epsilon naught q minus 1 by 2, and that will be the twice q into minus d divided by x square plus y square plus z square d square 3 by 2. And similarly for phi 1 dash, second part of this one is also related with the q dash, that is 1 by 4 epsilon x square y square plus z square z plus d whole square power half. So that phi 1 dash by the del z equal to 1 by 4 pi epsilon q in q dash minus 1 by 2 into the d divided by x square plus y square plus d square 3 by 2. So we can write overall this one del phi 1 by del z equal to the 1 by 4 pi epsilon on 1 q d x square y square plus d square 3 by 2 minus 1 by 4 pi epsilon q dash d by the x square y square plus d square 3 by 2, and that del phi 2 by del z in second medium 1 by 4 pi epsilon naught q double dash d divided by x square y square plus d square 3 by 2. So using these two equations we can write, please check the positive and negative signs clearly. Sigma p equal to the epsilon minus epsilon 0 q minus q dash multiplied by the d divided by 4 pi epsilon 1 x square y square plus d square 3 by 2, and for the second case, that is epsilon 2 minus epsilon 0 divided by 4 pi epsilon 2 q double dash d by the x square plus y square plus d square 3 by 2. So on rearranging this one, we can write sigma p equal to epsilon 1 minus epsilon 0 divided by epsilon 1 minus epsilon 2 minus epsilon 0 divided by epsilon 2 q double dash, because we have substituted the q minus q dash equal to the q double dash. So this is common, q double dash by the d into d 4 pi epsilon x square y square plus d square 3 by 2. Rearrange, on rearranging we can obtain minus of the epsilon 2 minus the epsilon 1 multiplied by the epsilon 0 divided by epsilon 1 epsilon 2 q double dash d 4 pi x square y square d square 3 by 2. But we know very well that q double dash equal to twice epsilon 2 divided by epsilon 1 plus epsilon 2 multiplied by the q. So overall we can write polarization charge density is equal to minus 2 epsilon 1 epsilon 0 epsilon 2 minus epsilon 1 divided by 4 pi epsilon 1 d divided by x square y square d square 3 by 2. So this will be give the polarization charge density, and this conclude that this is also depends on the epsilon 1 epsilon 2, that is the permittivity of these two mediums. So this is sufficient for today. Thank you very much.